My name's Cory Minton. I'm a Principal Systems Engineer for EMC in our Emerging Technology Division. I also have a really cool job of getting to lead EMC's Data Fabrics initiative, which is focused on getting all of our pre-sales people around the globe smarter and better prepared to help customers solve problems with analytics, big data, Platform 3 modern app development. So thanks for being here. We're going to talk today about building massive and super efficient indexer environments. Obviously, the indexers are workhorses within the Splunk context, and we're going to tell you how EMC helps solve some really interesting problems. As a disclaimer, I don't intend to make any forward-looking statements. If I do, then they're worth exactly how much you've paid me to be here, which is 0. So just understand that this stuff is, I'll try to be non-forward stated in my messaging. Okay. So part of the reason why some of you are here is that you're very excited not to hear this big dummy talk. It's that you're excited to get the chance to win this guy. So the story is, if you got your ticket, good. If you came in and you didn't get a ticket, raise your hand, and somebody will come around and give you one. Over here, we got a guy who didn't get one. And so if you stay to the end, we're going to raffle it off, and somebody will go home with a sweet BB-8 droid. Cool? All right. So hopefully you don't have to go to sleep or feel too painful sitting here watching this. Okay, so what we're going to talk about is really high levels of data and storage tech trends. I'm not going to teach you anything about Splunk architecture you don't already know, but I want to make sure that we level set some expectations around architecture and some fundamentals so that then you can understand the value proposition around why flashing your home path is so stinking cool besides just being on the back of a shirt. And then why the big cold data lake is actually going to do some really cool things for your enterprises in context of not only Splunk, but also in the other applications that exist out there around Hadoop, leveraging Hunk to connect the two, right? And we have a really cool story we're going to talk about there. And then we'll show you how we take all this cool technology, put it together in a simple converged infrastructure stack that makes it easy for you to manage. And then I'm going to show you some really cool apps, and we'll talk about some sweet ninjas that we got in the room here today too, okay? All right, so reality is data's getting ginormous, right? So we all knew that data was growing. That's not all that hard to figure out. But if you look at the way data's growing in the enterprise, it's growing in an unstructured way, not in a structured way, right? It's not the traditional databases and OLTP applications that are growing. It's all this new unstructured data stuff, which is why Splunk, its architecture, its focus on machine-generated data has been so cool. We, as a technology company, see this trend happening and coming and manifesting itself in the way that hard drives are being purchased, right? Hard drives are being purchased now for unstructured data for a lot more of them than are for structured. So it's driving a new use case. So if you look at the hard drive sales going forward in 2017, over 133 exabytes of hard drives will be sold for unstructured data. It's over 80% of the use of storage and storage media, which is kind of interesting. And it's important that we prepare for that by having applications, technologies, automation capabilities within our enterprises that allow us to deal with that massive deluge of data. So things like Splunk being an application designed to handle parallelizing of workflow, being able to scale out very linearly is important because there's not going to be 50 more of you in your organization to deal with this deluge of data. So everybody has to be able to handle more with less, right? That's the general idea here. So we think, as you look at this data growth pattern thing, and you look at the fact that we're not getting, budgets and IT staffing isn't following the same curve as the data growth thing, then we have to figure out architectures that are going to help us deal with it. So Splunk obviously follows the design paradigm of being very parallel or very scale out in its nature, right? If you start with one indexer, you can run Splunk on your laptop. If you want to grow, you can scale out to having hundreds of indexers to handle many terabytes of data ingest per day, have many, many search heads a part of a search head cluster to handle the scale of dealing with large data sets within your Splunk environment. So when we talk about storage platforms that are designed to work with Splunk, we want to make sure that we present to you storage platforms that follow this same design paradigm. Right? We don't want to talk about traditional monolithic storage arrays that really had a finite limit of growth, and it was really painful to have many of them kind of spread out in your data center. We want to make it, we want to show you some platforms that are scale out in their design as well, that allow you to, as you grow, simply add infrastructure, and the infrastructure is smart enough to take care of itself. Okay? So this is very important, so you'll hear us talk about some really cool scale out technologies today. Now, obviously you understand Splunk is awesome. We get it. I don't have to teach you guys this. But it's interesting because it's grown, right? I was here last year, and the Hunk conversation was different last year than it is this year, right? It's maturing, and we're starting to see that partially because Splunk realizes that the Hadoop ecosystem is maturing. The adoption rate of things like Hadoop is growing within the enterprises, and so we need to make sure that the smart folks that understand Splunk have the capability of leveraging technologies like Hadoop and leveraging data that exists in Hadoop for the purposes of query, right? And this unified query that's coming out in 6.3 is so rad, right? And that's awesome. So we want to help customers understand how you can build platforms to support the variety of ways that Splunk will instantiate itself in your environment, okay? So architecturally, clearly you got 3 tiers, right? You got your forwarders, send all the data to your Splunk indexers. Your indexers do all your heavy lifting, right? Splunk D does all the stuff, right? CPU and disk intensive. And then the search heads, not as disk intensive. They're a little bit more CPU and memory intensive. That's why you see typically like 16 gig, 16 core boxes in their reference hardware, right? So here, we're going to talk mostly about the indexers because those are the ones that are bound by CPU and storage that we have a really unique story for, okay? Just to be clear, it said right in the title it was about indexers. Okay, so when you start to look at your indexing environment, you have to think about the storage, and there's multiple ways to deploy storage to support your Splunk environment, as I'm sure you're aware. But there's some things to keep in mind as you begin to plan your Splunk deployment that you have to be mindful of in storage. So the first thing is you need to make sure that you meet the high performance requirements, specifically associated with that hot data and warm data that exists in home path, right? Because that's where most of our search is going to happen. We need that high performance, low latency storage. You also need to have a high capacity storage tier because this cold archive is a wonderful thing to help us offset the cost of that more expensive tier where we're more interested in performance. Where with the cold tier, we want to be able to have scale out capacity that gives us a great cost per terabyte, but allows us to keep lots and lots of data in band, right, in the query capability within Splunk. So it needs to be performant enough, but really optimize that cost per terabyte. Now again, you do have this scale out infrastructure, so you're going to have indexers scale out over time. You need to have storage that can handle that as well, and handle that elegantly. And then there's some things like data services like dedupe and compression that start to get interesting. And we'll talk about it. Out of curiosity, who in here in their Splunk environment is doing indexer clustering today? Right, many of you. Okay, cool. I can tell you what, first person that will shout out their rep factor and search factor settings. 2, 3. Boom. Rep factor and search factor 2 and 3. You mean 3 and 2? No, 2. Our rep is 2. We also have it backed up in Hadoop. Oh, cool. Okay. So we only need 2, 1 per site. Awesome. Dig it, man. Cool. So we're going to talk about that cluster indexing. Have you noticed that when you turn it on, it has a pretty big impact on storage? Right, chews up much storage. Splunk does a good job of compressing the data, right? The raw data gets compressed well. We're going to talk about how we can handle that. And then you obviously have some things like was said here in the front. You need to back up the data and secure the data very well. So when you start to consider storage platforms, you want to make sure that you look at platforms that can do things like Dratan talked about in the architecting for high availability, if you guys went to that session, that one of the best ways to protect hot data is to do things like a snapshot-aware file system for storage, right? That's the way you manage those in-flight reads and writes, and you have a consistent copy. So you want storage that can deliver that, okay? So we're going to talk about how we do that. Now, again, in that hot and warm bucket, right, in the archive, or in that tier, you really want that high-performance storage. Right now, sizing of the buckets and numbers of buckets do have impacts on performance, but in general, right, Splunk says for hot and warm, you can use either direct attached storage in the server, right, the spinning disks that go in your servers, or you can use a SAN technology, right, so block attached LUNs. This is cool because that gives us high performance, low latency access. You need to typically have, sometimes they say 800 IO, sometimes they say 12, depends on which reference you're reading. We generally say 1200 IO for that hot and warm per indexer. On cold, again, much more rarely used, rare searches, totally support NAS here. So you can do DAS, SAN, or NAS technology from a storage perspective in the cold tier, which is cool because NAS typically better cost per terabyte. Is anybody here doing frozen today? Okay, are you doing it because you have to keep it for a regulatory reason, or just? Okay, cool. Yeah, it's pretty common. The challenge, though, is that if you put data in frozen, it's out of band, right? You can no longer see it. You have to manually move it back into thawed in order to do any query against it. So we heard a session the other day talk about more data is good data, right? Because at the end of the day, this is all statistics, right? The more data we have, it's probably true that we're getting our sample size is getting closer to our population. So our ability to predict things and our confidence interval in that assumption should be higher. So we want to help you figure out ways to get data out of frozen, meet the compliance and the retention requirements, put it back in band so you can derive value from it, okay? So when you start to look at the indexes, you need to understand, right, the storage capacity impacts. So obviously, let's use an example of like 1 terabyte of ingest per day. As you have 1 terabyte of this log data come in, as it hits your indexer, those 2 sets of data are being created, right? We got the raw data that's going to be highly compressed, and then we've got your indexes, which are really uncompressed, and that's the good GUI bits that Splunk is going to have access to for search that's going to give us the power that we've seen all week on display, right? So when it goes to disk, that 1 terabyte typically gets written and compressed down to about 150 gig in this example, right, for the raw data, and about 350 gig for the indexes. And that's because if you think about it, Splunk in general, if your rep factor and search factor are set to 1, you roughly get about 50% compression, right? So you're going to get about 50% of whatever your ingest is what's written to disk. And then that's split up about, about 30% is your raw, 70% is your indexes. Okay. So then you figure out how much storage you need. It's not too hard to figure out. If I have a daily indexing rate, my license is a terabyte a day, and I'm going to get that 50% compression, I multiply that times my retention period, and that gives me a pretty good idea of my storage requirements. Now, that's the base level requirements. That doesn't include things like free space, like room for copies of indexes or anything like that, but it gives you the baseline of, at minimum, I got to have this much usable. Okay, so in this example, it's, let's say we keep it for 60 days, it's 30 terabytes. Okay, and that's broken up if you look at the raw and the indexes. It's about 9 of raw, 21 of the index data. Now, when you start to look at that indexer clustering, it's awesome because it does 2 things. The replication factor takes copies of your raw data and protects it across the indexes. And your search factor creates copies of your indexes to protect the indexes, right? And rep factor always has to be greater than or equal to search factor. And this is cool in that it gives you more high availability. It does enable you to do some more high-performance search, gives you some flexibility on search affinity, especially if you couple this with multi-site clustering. That's all good. But it chews up storage. Right? So if we set the replication factor and search factor to 2 in our previous example of 60 days and a terabyte, then now it went from 30 terabytes of storage I need to 60. And if I turn it up to 3 on both of them, then now I'm up to 90 terabytes. Now, there's a lot of value in indexer clustering. Now, the session that was in here previously was best practices, and people are very excited about it because it does help us solve one critical problem, and that is, as Splunk grows in its importance to us, to our organizations, as we start to expand our use cases of it, we need to start applying more enterprise class requirements against it, right, of high availability, data protection, security, uptime, right? And even if you heard Godfrey's keynote speech, he talks about at mile 8, one of the 4 critical components of Splunk's strategy going forward is focusing on those enterprise class capabilities, because Splunk is no longer this cool, like small software company that a few folks really use and it just had this small cult following that everybody loved. It's still that, but it's also huge in the sense that people use it for a broad number of use cases. Use it for business analytics. It's replacing traditional big players in business analytics. So things like indexer clustering help us get there with a few of the enterprise capabilities, but we got to be mindful of it. It's kind of expensive when it comes to storage. Is that fair? Okay. All right, so how big does it actually get? So I actually like this because this assumes a replication factor and search factor of 2, and it may be a little bit hard to see, but if you look at there's kind of a line that goes down like this that's a little bit darkened. If you download the slides, you'll be able to see it very clearly. But basically what this is saying is that anytime you get to a ingest rate and a retention period that starts to get north of 100 terabytes, it's going to start to get challenging to deal with it with traditional infrastructure. Whether that's traditional SAN or it's traditional DAS models, there's going to be a tip-over point when looking at external attached storage, looking at a model like EMC's for Splunk starts to get really attractive. It starts to solve some very real problems. So we've actually had customers that have, they're doing north of 6 and 7 terabytes a day of ingest, and they have retention periods that, because of a breach, the data is very important, they have a keep forever model now. Well, think about that. At 6 terabytes a day of just keeping it for 5 years, that's 11 petabytes of storage. That's just the minimum usable. How many of you folks have 11 petabytes of storage in your environment today? That's my guy right there. I like it, petabytes. So there's not a lot of storage platforms out there that can handle petabytes at a very elegant scale that don't include massive amounts of influence or massive amounts of time being spent by an administrator keeping the lights on, right? Petabyte scale still challenges. It doesn't for us, and we'll talk about how we do it. It's pretty slick. Okay, so I like, just so we're all on the same page, I like Splunk. What I'm saying here is that deploying it in a traditional direct attached storage server model does have challenges, specifically at scale, right? And small scale, it's not that hard, right? It's easy, right? And I'm not saying Splunk is complicated, but at scale, the infrastructure to support these environments does get sort of challenging. And here's how. First, it is a dedicated silo of infrastructure. That's traditionally something that most enterprises have tried to get away from. They've tried to get towards, you know, using a shared service model or using virtualized compute farms that we can scale very linearly, shared storage that we can, you know, start to scale out for many use cases so we get a better TCO. Right? Think about why VMware has been so successful in the marketplace. It helped companies stop building silos of infrastructure to support specific applications, and we better optimize our utilization of those resources. It's the same conversation here, right? Deploying Splunk and DAS has some challenges associated with it being a silo. Now, you do have some compromised availability. Hard drives fail, that's okay, right? But just having to manage them at scale, right? If you imagine having hundreds of servers, trying to manage the capacity you might need to get to that 10 petabytes, that's a lot of work, and we don't want you to have to do that. Now, index rebuilds also can take some time, and the other part of it is that the rebalancing, like if you want to grow, indexes don't automatically rebalance. That's a manual process, right? So you create hotspots within your infrastructure, which is sort of a challenge. Now, Splunk knows that they have some enterprise-class data protection, but it's limited to either indexer clustering and multi-site clustering, which if you step back to the more traditional infrastructure view, doesn't meet the traditional DR/HA requirements, which is why Splunk wants to talk about things like snapshots for protecting the data from corruption so you can restore more quickly, okay? So that's pretty interesting. Storage efficiency, it's great if your rep factor and search factor are set to 1, but as you crank it up, that creates mirror copies, and that is a lot of overhead. And that non-optimized for growth, that's basically saying that, yeah, we understand that Splunk has some reference architecture on kind of, you know, how many servers in the server build you need and the amount of I/O. But the reality is everybody's environment will be different based on their data sets that they're ingesting, their forward environment, as well as it may be different based on the queries or the applications you deploy. So you may find that your infrastructure is constrained not by the overall infrastructure, that it's constrained by maybe the CPU or the memory, or maybe it's the spindles that are too slow. Having the ability to scale those independently is pretty valuable, and in the DAS world, you don't have that. You only have one button to push in infrastructure. And then from a complexity perspective, again, it's not that complex. It's smaller scale, but we start to get north of that, you know, many terabytes a day and long-term retentions. This gets kind of challenging, okay? So now, here's why EMC for Splunk. This is kind of our big picture slide, and we're going to go into these in a little more detail, but here's what it is. We've built, you've probably heard of EMC Storage Company, but we've built some platforms through acquisitions and through some of our own, you know, some own engineering activities that are optimized for the Splunk workload. We've got platforms that are designed for this hot and warm type data, that high performance, low latency, scale out in our XTREMIO all-flash appliance and in our SCALEIO virtualized SAN appliance. For cold data, we have Isilon, which is a scale-out NAS platform that is Gartner and IDC's highest-rated NAS on the planet. It's the largest enterprise-class NAS, and it delivers a ton of data services that we'll talk about that are super valuable. And at scale, we really have very little competition in terms of simplicity of management. So you take those cool storage platforms, and now we put them together, and we actually build converged infrastructure where we take assets from our VCE organization, which was a joint venture between Cisco, EMC, Intel, and VMware, and now we can stand up complete converged infrastructure, meaning servers, network storage, all the orchestration and automation designed and optimized to run Splunk efficiently, so you don't have to integrate components, you focus on deploying Splunk. Okay? So we take that, we have these scale-out platforms that have great cost and great flexibility, but oh, by the way, we deliver some data services that nobody else has figured out a way to deploy. And that is, we do encryption and security better than anybody with XTREMIO and with Isilon, data at rest encryption. That's not something that's easy to do with Splunk typically, right? And for many of you that work in highly regulated environments, this will become important to you. We also give you the ability that across platforms, we support snapshots that are very space efficient, that gives you that rapid capability of restoring data and handling index failures, right? Index losses. Now, one of the big things that we kind of hit on early on was this concept that indexer clustering is awesome, but it creates some overhead. Well, with an XTREMIO, we have inline deduplication that will actually cancel out all of the overhead associated with whatever you turn your rep factor and search factor to in terms of how it's written to disk. Splunk still sees it. You still get the benefit of indexer clustering, The storage is just smart enough to deduplicate the actual blocks that get written to disk. And in this case, it's an all-flash appliance with unmatched performance. Okay, very, very cool. So we do compression and deduplication as well as those other data services. All right, so let's dig into them. Why are people talking about flash now? Well, let's just be honest, it's fast, like duh, we know that. But the reality is that flash was really attractive years ago, but it wasn't cost effective, right? You had to be very selective in how you deployed it. But now, with intelligent storage arrays like XTREMIO that actually can take this flash technology, layer on top of it intelligent storage software that gives you data services like data deduplication, compression, encryption. If you could do that at those data services now, an all-flash appliance becomes as cost-effective from a TCO perspective as a spinning platter array. And we'll show you how we do that. It's pretty interesting. But now we're starting to see as those flash prices have continued to go down and our ability to deliver data services has gone up in the storage software layer, that the overall TCO has just gotten way more attractive. So if you need that high performance, there's no better way to get it than this. Now, XTREMIO does a couple things that are really cool. One, it's always on thin provisioning, so there's very little interengagement in terms of how you actually provision storage. It does inline deduplication. It does inline compression. We apply that XTREMIO data protection to intelligently write bits of data to disk to handle hard drive failures. We do that data rest encryption, and we give you agile writable snapshots. So by giving you these data services, now we're doing things that Splunk doesn't do natively, but we're doing it at the storage layer, so that Splunk runs better, so that you can restore Splunk faster, so you can protect it better, so you can replicate it easier, okay? Now, XTREMIO for Splunk is kind of interesting, mostly because the thing is freaking fast, okay? It's a scale-out architecture. Starts with a single brick. A single brick has a couple controllers in it, a bunch of memory, a bunch of SSD drives, and it has software that runs on it. Each brick, marketing will tell you that there's like, oh, you can do 1 million I/O per brick. The reality is with Splunk, what we're finding, about 150,000 Bonnie++ IOs per brick. We haven't tested it all the way up to maximizing, but we've seen, as we've done the 500 gig, 1 terabyte and up, testing on Bonnie++, it's scaling linearly. Every time you add more indexers, it's factoring the IO production. And actually, if you go by our booth, we have a published white paper that talks about XTREMIO and some of the testing we did for Bonnie++, showed over 45,000 IO with only 8 indexers doing a terabyte data test, which is pretty rad. If you look and compare that against the published Splunk metrics that they have from a couple years ago, it's 52 times faster. That's pretty good, right? So now we're talking about ultra fast, scale out. I can start with 1 brick, but I can go all the way up to 8 bricks. So you can start with one of these things and start adding one at a time, and it scales linearly. And that goes all the way up to, again, if I have 150,000 IO capability per brick, I put 8 of them together, I'm over 1 million IO in a cluster. Does anybody here want 1 million IO for their Splunk environment? Yeah, that's right, you should. It's awesome, right? Why not 1 million? Let's do teraflops of IO, right? Let's do it. Okay, so it's also low latency, which is super cool for hot and warm data. We love that. Okay. So obviously the whole concept here is speed is the name of the game for hot and warm, but it's also got to be cost effective. So those data services get really interesting when we do that deduplication and we do that compression. What we typically find is that Splunk doesn't typically dedupe very well. If you have a rep factor and search factor of 1, it doesn't dedupe very well because Splunk already does a good job of compressing the data. If you're doing indexer clustering, this gets really, really attractive because that deduplication rate that you'll see with XTREMIO will typically be about what your rep factor and search factor settings are. So if you set them both to 3, your deduplication rates will be about 3 to 1, which means your storage will always consume, you'll always consume the same amount of underlying disk, no matter what you set those factors to, okay? Very, very cool. Okay, now we also have SCALEIO. So if you have a large-scale implementation already of a bunch of DAS servers, like servers with direct touch storage, but you really want to layer on some better data services to handle things like hardware failures more elegantly, be able to handle non-symmetric server builds. So if you want to have things like introduce a server that maybe has a bunch of flash in it, where traditionally maybe you bought servers with SAS, and you want to effectively use that across your indexer environment, then SCALEIO gets very, very interesting. It's a software that runs on your servers that virtualizes the underlying disk in each of those servers and creates a virtual SAN. So now we can take advantage of those existing investments, layer on some data services, get aggregate performance across those pieces of infrastructure, and simply scale out in a converged model. So if you like this model and you have this big investment, that's great. We also have a model now where we're deploying this as a converged infrastructure you can buy from us, either as what we call a SCALEIO node, or what you'll hear from VCE shortly is called VX Rack. And we'll talk about that shortly. It gives you the ability to have really intelligent storage services, but on commodity hardware, okay? Now that's how we're sort of seeing the world go, right? Everything's sort of trending towards commodity. Okay. Now, that's for your hot and warm. For cold, Isilon is absolutely, well, it's the best platform within EMC for cold, and it's partially because, think about it, Splunk Enterprise today says point blank, NAS is for cold or standard DAS. Isilon is a scale-out file system. It starts with 3 nodes, scales to 144 nodes, smallest is about 10 terabytes, at scale 50 petabytes in a single volume, single file system, single namespace. As you add nodes to the cluster automatically rebalances storage so that you have a homogeneous distribution of data across those pieces of infrastructure. This is really slick because now, as it scales out, it's not only getting more capacity, but because it's a node-based architecture with the CPU and memory in each of the nodes, the whole file system gets faster. The whole file system gets more efficient. So it truly linearly scales. If you don't know much about Isilon, I highly encourage you to stop by the booth and talk to one of our folks. It is by far the coolest NAS platform out there. And if you read the analyst white papers on hardware and stuff like that, the register is one of those ones that's like the third party that like picks on everybody. But they have kind of this running joke that they're hoping somebody finally comes up with a NAS that can compete with Isilon. So it's a really good place for us to be competitively, but our customers are adopting it at a phenomenal rate. We bought Isilon as a company about 5 years ago. When we acquired the company, they were doing about $230 million in revenue. It's over $1.2 billion now. So people are voting with their dollars that they really like this thing because it does what it says it does on paper, and it's really simple, and the sales guys didn't lie to them, okay? Now, Isilon for Splunk is nice because, again, we have this concept of as I just need to add more cold capacity, I'm probably not needing to add a ton of performance in terms of my indexers. I really just need that capacity for retention and those rare searches. So Isilon scales out linear. Now, Isilon is also the only enterprise-class NAS appliance on the market today that operates HDFS, the Hadoop Distributed File System, natively as a protocol. Now, this is big. If you have both Hadoop already running in your environment and you have Splunk, we give you the capability of combining the underlying storage for those without breaking the overarching applications that are used to run the apps, right? Whether it's Yarn, MapReduce, whatever flavor of Hadoop you're running. This is really interesting because now, especially with like Hunk 6.3, people are getting really excited like, ooh, the guys in marketing said I can lower my cost of storage by 70% with using Hunk. Well, I kind of wonder how we get there, but here's one thing I know you can do. If you want to write your cold archives to an NFS volume and you just really always want it in enterprise, great. Isilon runs NFS as a protocol. You can write the data there. However, if you want to write your cold archives down to a Hadoop file system so that then you can expose that data to other services like Hive or Pig that were talked about in the Hunk sessions, great. You can actually write it to Isilon because we run HDFS as a protocol natively. Write it to Isilon, let the Hadoop translator do what it does of stripping out the unnecessary data so it's optimized for Hadoop. And guess what? Now you just point your Hadoop clusters at the Isilon, or your Hadoop compute nodes at the Isilon. It's there. It also gives you the ability that because we decouple storage from compute in the Hadoop cluster, you actually need many, many less compute nodes in your Hadoop cluster than you would traditionally, which means your cost for Hunk goes down. Okay, so if you have questions about Hadoop and Hunk and Isilon, please stop by the booth because it is a really rad story. David's back here. Where you go, David? He's chomping at the bit to tell you about it. He's an Irish Aussie. He's awesome. Okay, so Isilon, not only a NAS that scales out and does what it's supposed to do, it also does data services like an enterprise class storage should. It does have those self-encrypting drives. It does do snapshots. It does replication. But oh, by the way, it also does things like deduplication so that overhead associated with those indexer clusters go away, right? That's pretty cool. Now, we also do some things like we talked about frozen is, typically we really only have it around because you have to keep data for some compliant retention reason. Splunk doesn't do a really great job of enforcing like worm type compliance yet. They'll get there eventually. Isilon does. So if you have data that you need to prove that it's audit worthy and capable of being kept for a particular period of time, and we're protecting it from things like clock hacking, Isilon does that natively with SmartLock. So very cool if you have a highly regulated environment. We solve and check some of the boxes that are enterprise class requirements. Now, when we talk about Hadoop, one of the things that we're starting to see, and you probably, if you have both Splunk and Hadoop running in the environment, I know one guy back there does, a good customer, you start to see silos, right? Where you've got Splunk running in this silo over here, and then you got some other business unit that wants to run, Hortonworks, and they want to do some Hadoop stuff. And then you got somebody else over in the other corner, other part of the business that happens to run IBM's Big Insights, right? They love that. Or maybe you got some traditional BI stuff going on SaaS, right? Pretty common. Does anybody have at least 2 of these? Does anybody have all of them? I'll give you a t-shirt if you do. How about of the 6, 5 of them? 4? Ah, okay, 2 t-shirts. I can't throw that far. I got one for you over there. Oh, I overthrew it by a mile. I can throw it that far. Oh, I'm an overthrower. Awesome. Sweetness. All right. So here's the deal. Silos. Whoa, am I good? All right, they're all silos. That's not a good thing generally. That means somebody's buying infrastructure, having to manage it. It's taking up space in the data center. It's got a different depreciation life cycle than other stuff does. It's getting capacity utilization that's different. Isilon gives you the capability of taking all of these workflows, putting them into a single consolidated data lake that provides all those data services, provides 80% storage efficiency, so you're very, very efficient storing data, and exposes data via the protocols or access methods that those applications know and love. So if you have data that maybe comes in via Splunk and Hunk, it gets written via NFS or HDFS, that data is now accessible via any other application that uses anything like HDFS or NFS. So SAS, for example, SAS loves putting SAS data on NFS. SAS Grid still sits in a compute. SAS data runs on NFS. Isilon's got a great story there. If you have Hortonworks, Hortonworks has certified Isilon as an HDFS storage appliance. So if you want to use Hunk to write some of your cold archives there, but you want to expose those cold archives to your Hadoop team that wants to run some queries in Yarn against the data, guess what? They never have to pick the data up and move it. It's all in the same file system. Now remember, we said at the beginning, data is becoming big and unstructured data is becoming this big thing. Moving data sucks, right? Networks, it clogs it up, it's too big, right? How long does it take to move 100 terabytes across a 10 gig link? It's 27-something hours, right? That's a long time to wait if I want to query that data set. That's time to value. That's slowing my smart guys down from learning things from the data. So don't move the data around, put it in the data lake. Now, EMC's done a lot of work to make sure that we don't just come up and tell you this stuff works. We've actually done the work, thanks to a couple of folks in the back of the room that have been doing some really hard work, making sure that we test this using the benchmark tests that you guys use, that Splunk uses, so that we know the stuff works. We know it's integrated. We know the data services are there. So if you want to understand what we've done to date, we've got some reference architectures that go into some of the testing results. They go into some best practices for deployment. And we're happy to share those with you. We have some printed at the booth, but we can also send you these links, and they're available in the slides. So the reference architectures, again, really include the concept of XTREMIO for that hot and warm data, Isilon for your cold data, allowing those awesome scale-out architectures to deliver the scalability and predictability over time that you'd expect, while adding those data services that make it super simple to manage in the data center, but also protecting the data and protecting you from those enterprise class requirements that you know are going to come down the pipe, okay? So now we take all that together and we wrap those reference architectures up in a converged infrastructure offering. Again, VBLOCK from VCE is taking Cisco UCS compute, Cisco networking, combining it with EMC's best of class storage technologies, and pre-integrating them. And when I say pre-integrating them, I literally mean we get all the components from the manufacturers, we build these things in a rack, we turn them on, we pre-test them, we preload VMware so that when it ships to you and it shows up, you plug it in, power it on, turn it on, start deploying machines. The reason why customers buy this is typically because they want a couple of things. One, I want really fast deployment. Had a Splunk customer in the Northeast that needed, from the time they purchased hardware, they needed hardware deployed in 45 days. So within 45 days, it actually ended up being a little bit less. We actually took an order, built a VBLOCK configuration to support their Splunk environment of doing 4 terabytes of ingest per day using ES and some other components, and within 45 days had an infrastructure stood up in the environment that they could start deploying Splunk on. Okay? Now, this is really cool, not just because, oh, we pre-tested it, we pre-integrated so you know it works. It shows up already built, but it also comes with one number for support. So instead of your infrastructure folks having to call, oh, it's a server problem, or it's a network problem, or it's a storage problem, they don't call different people, they call one number. The entire stack is updated in what we call automated release management. So instead of having to deal with Patch Tuesdays, and you update the HBA and you break something on the server, that doesn't happen. We test the update across the entire stack, and we ship it a couple times a year that upgrades the entire stack seamlessly. Okay, that means that your folks don't spend time focused on making sure infrastructure is integrated. You spend time on the applications. How many folks in this room would say that their company is making money and producing revenue because they are better at integrating components of a data center than than their competitors? Well, the EMC guys should all raise their hands, but right, that's not right. So nobody does that. So this gets you out of the business, right? How many of you folks here buy laptops? Well, you buy laptops. You don't build them, but you can. You could. Why would you? That's work you don't have to do. You got one number you call for support, it's easy. Same idea, right? Get infrastructure off the truck that works, and you know it works. It's one number to call, one throat to choke, okay? Just, if you think of it no other way, it gets you out of the business of fooling with infrastructure, so you can go Splunk stuff. Now, we have a couple of instantiations of how VBLOCks get shipped. The first and most common that we're seeing today with Splunk customers is our VBLOCK 540, which means it's Cisco compute. We size that using Splunk best practices around, you know, the number of indexers you need, right, the number of cores and memory, right? So we have regular conversations with them to make sure we're doing it right. And then we use XTREMIO as the hot and warm tier of storage and Isilon for the cold. Then we also have this thing called VX Rack, which takes commodity off-the-shelf hardware, bundles it together in a VX Rack, and runs SCALEIO as the storage software. And then you can run that for hot and warm, or and with Isilon as a cold tier, or you can actually have multiple tiers of this VX Rack concept in the same cluster, which is very, very cool. So that's the hardware and kind of story. I want to share with you a couple of really sweet apps and talk about our ninjas. All right, so for VCE, we will have an app out shortly called in Splunk for VCE Vision. This is going to give you the ability that if you're a VBLOCK customer or you're somebody in your data center has a VBLOCK and you'd like to use Splunk to monitor that infrastructure, they're going to have an app out for that very shortly. Now, really neat, if you have XTREMIO or Isilon already today, there's apps available that you can actually go monitor both of those platforms using Splunk. We used an application development company that's here this week to build a really nice set of apps that understands those data sources they come in and has built some very feature-rich dashboards so you can really understand how the infrastructure is performing. So not only are we asking you to bring your Splunk data to EMC, we're allowing you to Splunk your EMC. Cool? All right, so how do we size infrastructure? We try to follow Splunk's best practices religiously. If you have a question about Splunk best practices, come find us because we're trying to learn them as fast as we can. Most of us have been through a bunch of these sizing. Many of us by the end of the year will actually be Splunk certified, but we listen to what Splunk says and we try to default to their opinion because we don't want to tell you something different than them. It's their app, right? So we want to try to follow their guidance. So we always try to build converged systems first because we know the value is there for our customers. So don't be surprised if you have an EMC conversation. They're going to talk to you about VCE because there is real value in not having to build that stuff and integrate it yourself. But we'll certainly talk to you about storage platforms and how you can step into any one of these with your existing investments. And now we have our own ninjas to help. So EMC recognized Splunk as an incredibly valuable partner to us. They're an incredibly valuable partner and vendor to our customers. And we have a lot of overlap in terms of Splunk customers being EMC customers. So what we wanted to do was get some folks in the field that are engineers, really, really smart about Splunk so that they can help our customers solve real problems using EMC technologies. So we've got 30 people globally that have been assigned to the Splunk Ninja team. So it's an EMC Splunk Ninja team. You'll see them. Most of us have on the cool shirts. These guys are here. We've got 20 of them here from around the globe. There's guys from Korea, from Australia, from Singapore, from all over the US here, right, that are excited about Splunk, that are as excited to be here as you are, maybe more so. Find them, ask them questions, because they're all trying to learn, and they may know some stuff on how to help you solve some real problems. Now, I know Splunk doesn't officially support this application, but they talk about it in a bunch of their decks, and we really like it. If you have questions about this storage sizing stuff, this is by far the easiest app out there. We use it in our sizings because it is really, really handy. Has anybody seen that before, this little app? It's awesome. I mean, it's so easy. You literally go in there and you select, okay, what's my daily ingest volume, right? Oh, what's my retention period by tier? How many nodes do I want? Boom, it spits out exactly how much capacity you need per indexer, as total, and then it actually allows you to do things like if you're going to do DAS, pick which RAID sets, RAID distributions you want, and it actually spits out the conf file. So actually you can copy and paste the configuration straight out of there into your conf file. It's pretty rad. We use it. Okay. Again, the whole reason why EMC's here is because we have awesome platforms to make Splunk run faster, to give you deeper storage for long-term archive and for cold archive, to make that data available via many, many platforms, support you as your data lake goals of having lots of different applications use the data without having to move it, and bringing those enterprise class capabilities that has made EMC what it is today as a $22 billion market leader in infrastructure. We know how to build enterprise class components. We're bringing that know-how to Splunk. So thank you for being here. Now we're going to do a little bit of a raffle. While we're coming up with the raffle, anybody have any questions? Yes, sir. There are, but they're not officially supported by EMC, so they've been community built. Oh, I apologize. He asked, are there any applications out there for Splunk apps in Splunk base for our other storage platforms like VNX and VMAX? There's not today that are officially supported by EMC. There are some community-driven ones, and they're pretty useful. If you have questions about them, I think Jonathan's played with a few of them. Some of the folks in the room have played with them. But you can go out and download them. I mean, they're free. There's no cost associated with them. But our goal is that we're trying to, by the end of next year, have apps for most of the platforms within EMC's portfolio. Good question. Oh, it does? Brilliant. I didn't know that. So she said the VMware, the VCE Vision app covers VMAX and VNX. So check that out. When is that out, Jamie? October. So VCE Vision app for Splunk, October covers it. That's awesome. I didn't even know that. I learn something new every day. Questions? Anybody else? Yes, sir. Do you have anything similar to the Hadoop Connect app for doing exports between? We don't really need it because at the end of the day, oh, sorry. So the question was, repeat the question. I'm terrible at this. He asked, do we have anything like the Hadoop Connect app? The reality is that we don't need it because we just expose HDFS as a file system. So if you're using Hadoop Connect, you would still point it at, let's say, your Hortonworks cluster. Or you run a Hortonworks or Cloudera? Cloudera. Okay, so you'd run it, you'd point it at CDH, and the compute nodes would then say, I want to write this data to this Hadoop file system. We're just a file system under the covers. So anything that you're doing with Hadoop today, we don't really break. Yeah, we play nicely. And if you're using Hadoop, if you're using Hunk, same story, right? We don't break anything because again, we're just exposing HDFS to the compute nodes that may be running Cloudera, Hortonworks, or whatever. All right, let's draw for this thing.
So if you don't win, they can come back to the EMC booth. We're doing another drawing today, but you have to get a new ticket. We're doing the second drawing at 5:45, and then another one at 2:45 tomorrow.
All
Drum
right.
roll. Good luck.
All right. Ticket number 273 4819. Yeah, is this you? Yeah, congratulations.
Thank you.
Congrats. Thanks for joining us.
Thank you. If you could hang out, we just need to take a picture. Sure.
Yeah.
Okay.
Thanks
everybody.
for joining. Y'all have a great one. Come by the booth if you have any questions, guys. Thank you.